converters. Welcome to the plus 10 video from this 2+10 playlist of Diesel Tent 2.0, converting a van a slightly different way. Okay, so if you're new to this channel, there's a link up here and a card at the end. You can click on that, it'll take you through to a video saying why we're doing it differently, what we're doing, a bit about the design concept and a bit about the nuances around this particular build. But if you're a regular subscriber, you know why you're here. So without further ado, let's get into the video. Okay, first of all, if you've clicked through from the 2-minute brief update, apologies, there will be a bit of duplication to start with, but definitely hang around to hear the very interesting stuff I did when I was stress testing at high currents and discussions with Fogstar if you're interested in that sort of thing. Okay, so regular subscribers will have seen me do the mock-up with foam models of the electrical system, see if I could squeeze a ridiculous amount of kit into a ridiculously small space. Link up the top if you haven't seen that. And then I did some basic setup testing with a lead acid battery, and now I've got the Fogstar Drift 460 amp hour battery. It's time for the real thing. So I'm going to test the Victron AC to DC charger and charging circuit, the Victron MPPT solar controller. I'm going to jerry rig up the solar panel I've got, and then I'm going to do some really seriously heavy stress testing of the system as a whole, running that inverter at high current for about an hour. Got a laser spotter temperature device so I can check out the crimps, the bus bars, the fuse connections, all that sort of stuff. So let's have a look. So that's the Fogstar Drift app with the AC to DC charger doing its thing. I've got it at 15 amps at the moment. It goes up to 30 amps. I'm trying at different current settings, but yeah, all looking good on that one. So I've done a lash up with my solar panel. It's a 610 watt solar panel, just to get it in a position so I could test the MPPT controller, and wires all over the shop, lashed up in there. So let's open up the Victron MPPT app and have a look. Yep, we got power going in, jolly good. Now let's flip across the Fogstar app to see if it's actually getting into the battery. There you go, excellent. So all good on the charging front. Of course I can't test the DC to DC until it's in the van. But I did put some 12 volts onto it to make sure everything fired up and I could hook the Bluetooth up and all is good there. But that final testing will have to wait. Okay, so now what I want to do is some quite heavy stress testing of the kit. So, you know, when I was in prototyping engineering, that's what we did. We severely stress tested our kit before we went into production with it. And this is what I want to do here. So my plan was to hook up a fan heater to the system and run it at full whack, which is just over 2 kilowatts, and run it for about an hour. Then I'm going to go around with the laser spotter temperature device just to make sure the crimps are good, all the connections, bus bar, fuses, all that's very good. Yeah, I'm expecting a bit of warmth there. It's 12 volt after all, and I know why some people like to go with 24 or even 48, but I've got very, very short runs on the high current cables, so expecting everything to be good. And bearing in mind, I have had very little experience of high current DC circuits. When I was in prototype engineering, yeah, we were multidisciplinary stuff. My primary degree is in mechanical engineering, and I work with AC high tension engineers, signal engineers, general electrical engineers, and we were all mucking in together. So we picked up a lot of each other's disciplines, but not high current DC circuits. So everything was pretty good. All the cables connected pretty good. But when I moved the spot onto the battery terminals, wow, it was hot. Both of them were hot. Positive was getting on for about 35 degrees above ambient. I think it's about 33. And the negative just under 30 degrees increase above ambient, which shocked me. I thought something's definitely wrong here. Checked the crimps, they were good. In fact, as I took the spot off the post towards the crimp, they got cooler. So it was definitely the post. It was well torqued down. So, time to get hold of Fogstar and ask them about it. They came back and said, actually not necessarily wrong, but could you do these checks to test things out for us, including running different cycles and the casing. Very good support from them. And I did that, and there's results up here. But actually, by pure sort of fluke, I thought, I can't be able to wait for Fogstar to get back to me. I'll see what ChatGPT's got to say. And that suggested that actually the increase in above ambient I was getting was about right, which surprised me because I don't know about this stuff, you see. And what ChatGPT asked me some questions like how long is the stud length of the terminal? I didn't know, I guessed it 25 mil. And asked me about the length of the cable coming off the battery terminals to the isolator and bus bar. And interestingly, apart from, as I said, giving me the sort of numbers I was seeing, it suggested if I had longer cables coming off of the battery, I might see a reduction in the increase in ambient temperature on the battery posts, which instinctively I thought was odd. But I do have very short cables on that system, and what it's saying, of course, is the predominant heat is being generated on the post. Yeah, there will be some warmth generated in that cable, but predominantly it's on the post. Second law of thermodynamics, heat travels from hot to cold, so the cable is effectively acting as a heat sink. So it's suggesting if I had a longer cable, it would be a better heat sink, which I don't want long cable, of course. I deliberately designed to have very, very short cable runs. So that was really interesting. That and the information I got back from Fogstar, which was the results of the test gave them confidence that everything was all good. Yes, I was doing a very, very severe test, but it was useful to do it. And so I think that's stress testing complete. Okay, so thanks for watching. I'm going to build up a list of chapters in the comments down below so you can see what I've done and you can just click through what you want to look at. But in the meantime, please click that subscribe and like button and I'll catch you in the next one.